I'd like to welcome everyone to the Clean Energy Seminar. It is a vehicle event, and I would like to welcome you to this event, and very good evening to all of you who are joining from Bangladesh, and also uh, uh, the participants who are joining from US. Good morning, and also, I believe that there are some international participants as well from other countries. So wherever you are from, so thank you for joining, and good morning, afternoon, and evening again. So our today's seminar is about clean energy, and we are calling this, it's a Rehiker event. So I'll give you a very brief introduction to what Rehiker is. But today's so this clean energy seminar is actually organized to draw attention of the people who are interested in clean energy research and development. So throughout this series, we'll hear from energy experts from home and abroad who are contributing relentlessly with their knowledge and expertise in this area for developing clean energy technologies and clean energy careers. So this is the very first event of this clean energy seminar. And as I said, that you might be curious about what Rehiker is. Rehiker is actually a renewable energy project. It's a clean energy project funded under PR Cycle 9, funded by USAID and implemented by the US National Academies of Sciences, Engineering and Medicine. The title of the project, Rehiker, came from this broad title, which is renewable hydrogen generation with carbon recycling from biogenic residues of Bangladesh. So this project is actually focusing on producing hydrogen for our renewable energy carrier from biogenic residues. And because of this, its relevance to clean energy, so we are focusing on the clean energy generation from different sources. Now, Rehiker is a consortium of 4 universities. Department of Chemical Engineering, Bangladesh University of Engineering Technology is the lead for this project, with the partners, Department of Farm Power and Machinery, Bangladesh Agricultural University, and Department of Applied Chemistry and Chemical Engineering, University of Dhaka. We have Department of Biomedical and Chemical Engineering and Sciences, Florida Institute of Technology, as our peer partner from the US. So all these universities, from all these universities, we have faculties and dignitaries who are contributing to this project with their expertise in this area. And if you're curious about this project and future events under this project, so I would encourage you to visit our project website, which is rehiker.com, very simple. So you go to rehiker.com, and then you will find also the Facebook page link at the rightmost corner of this website. So you can also visit the page and follow that for future event announcements as well. And without any further delay, I'll move on to our event proceedings. Our first talk is about a very interesting topic in the context of Bangladesh, which is biogas. So we know there are existing biogas plants in Bangladesh who uses anaerobic digestion from single feed. And still, we can see that there is a research and development in the last several years, which shows that actually there are more efficient ways of producing biogas by introducing multiple feeds, by optimizing the biogas production. And our today's speaker is Professor Dr. Chayan Kumar Saha from Bangladesh Agricultural University. So before I go into any further details about the event, and also I'm going to introduce our speaker and our expert panel discussants, I'd like to give a little bit of overview of our house rules today. So at first we will go through the talk, and after the talk we'll have a panel discussion. And during the panel discussion, we'll be able to introduce the questions that you are going to ask throughout this session. And I would encourage you to write your questions or type in your questions in the chat box, and we'll try to pick up most of the questions from the chat box and include that during the discussion session. And after that, there will be a very brief session which is open to the participants as well, but that will be the end of after the end of the session, after the discussion session. So therefore, I would not recommend you to wait for that. So I would encourage you to type in your questions, all the queries that you have during the talk and also during the discussion, so that we can take up beforehand. So with that, I would go back to our speaker introduction. Our first speaker of this clean energy seminar is Professor Dr. Chayan Kumar Saha, who is a professor of Department of Farm Power and Machinery of Bangladesh Agriculture University. He has completed his bachelor and master's from Bangladesh Agriculture University. After that, he has completed his higher studies in Netherlands and also in Denmark. After that, he did his postdoc in Leibniz Institute for Agricultural Engineering and Bioeconomy in Germany. And apart from that, he is also visiting a scholar in Asian Institute of Technology in Thailand, and also Purdue Agricultural Air Quality Laboratory, Purdue University, US. He has received several research awards and also contributed significantly in the area of anaerobic digestion of biogenic residues in Bangladesh. And his current research interest in conversion of biogenic residues to biogas and also solar energy. He has currently 66 published journal publications and also 59 conference contributions he made. Along with that, he has one book and he's a reviewer for more than 12 international journals. So that is the introduction of our distinguished speaker today. And with that, after the speech, we'll have a very lively discussion with our expert discussants. One of the discussants that I'm going to mention here is actually involved with the biogas field for more than 20 years, and he has seen all the ups and downs in the biogas industries of Bangladesh. And he has been involved in several projects which are related to the implementation of anaerobic digestion in Bangladesh. So he's none other than Mr. Abdul Gofran. He's the ex-chairman of Bangladesh Biogas Development Foundation. With that, we have one expert panel discussant from US, who is Dr. Toufiq Reza. He is the assistant professor. He's the assistant professor of Florida Institute of Technology in US. He is involved with research related to waste valorization, waste to energy. He has been funded with several multi-million-dollar projects from with national funding to convert waste to valuable products and energy. And he is one of the projects is related to anaerobic digestion, to how to process the byproducts from anaerobic digestion. So I am looking forward to a very exciting talk and a very exciting discussion after the talk. So with that, I would like to request our speaker, Professor Chayan Kumar Saha, to take the floor.
Thank you, Dr. Kawnish. It's my pleasure to present in this seminar. Can you see my screen?
Yes.
So, good morning, good evening, good afternoon to the participants joining from home and abroad. I'm Chayan Kumar Saha, welcoming you my presentation. Title is Anaerobic co-digestion of biogenic residues, a potential solution for sustainable biogas production in Bangladesh. The content of my presentation would be, I will provide some background and then give some brief introduction on the anaerobic digestion and anaerobic co-digestion. Some of them might know about this anaerobic digestion and anaerobic co-digestion. For some of them might be unknown topic. So, and then I will try to give anaerobic digestion practices in Bangladesh. I will provide some overview on that. And then biogenic, that is residues available in Bangladesh. And then I will talk about potential of anaerobic co-digestion of biogenic residue in Bangladesh. And there will be some conclusion and recommendation. As you know, energy is a crucial input for economic development and improving quality of life. And per capita electricity consumption of Bangladesh is about 378 kilowatt hour, which is quite low than other developed countries. And around 51.77% of electricity is generated from natural gas. And by 2030, the shortage of natural gas will depend substantially. So that means there will be a crisis if we don't think about the alternative ways. So transition from fossil fuel to cleaner and sustainable energy is one of the major challenges in ensuring the energy security. On the other hand, if we look at the cow dung and rice straw, the biomass which are available, that is being used for fuel purpose. And because of that, organic matter is depleting from the soil. And at the same time, greenhouse gas is emitting from the traditional cooking system. And also there is a 70% heat energy loss. Recently, we have seen the news that mysterious plumes of methane gas appear over Bangladesh. It's not the mysterious, it's the reality because of the landfilling or the open dumping of the waste, the methane is generating, a greenhouse gas is generating from this waste, and that particularly would be vulnerable to extreme weather events and rising ocean, the country like Bangladesh. So renewable energy is one of the best options to make energy system of Bangladesh more sustainable. In line with the Sustainable Development Goal 7, that is affordable and clean energy, set by the United Nations, government of Bangladesh also has set plan to generate 10% of electricity from renewable sources by 2020 and 20% by 2030. However, the current share is only 1.63%, and mostly these are coming from solar power and hydropower. Wind power shares only 2.9 megawatt, and there is a significant, less significant contribution of biogas and biomass to the electricity. So one of the avenues that has been under scrutiny is the transformation of biogenic residues from animal farming, agricultural activities, municipalities to energy, which are not being utilized to their maximum potential. So we need to think of how to best utilize these biogenic residues. So anaerobic digestion, which produce a clean energy biogas from biogenic residue, may offer a sustainable solution, at least in part of the problem Bangladesh is currently facing. The current practice of AD is in Bangladesh with the single waste or substrate, and that might be associated with certain drawback. What are the drawbacks? They say might be unbalanced nutrient, rapid acidogenesis, poor buffering capacity, high ammonia and nitrogen concentration, and inhibition of long chain fatty acid, which may inhibit methanogenesis process, lead to severe instability and process disruption. In Bangladesh, in 2016 estimate, there are 91,350 small to large biogas plants, which are mostly fixed dome type, having poor efficiency, and these are based on the single substrate, and major portion of the plants are not working properly because of the poor management. So to overcome the mentioned problems, a recent and notable trend in other countries that can be seen, the anaerobic digestion practice, they are actually following the anaerobic co-digestion, which can be adapted effectively by using biogenic residues that are available in Bangladesh. So before going to the available biogenic residues and present state of biogas practices in Bangladesh, I would like to provide little background on the anaerobic digestion and anaerobic co-digestion. Anaerobic digestion is a series of biological processes in which microorganisms break down biodegradable material in the absence of oxygen. And this AD produce high value bioenergy from organic waste in the form of biogas as a renewable energy source, and digested bioslurry as an organic fertilizer, which can be applied to the plants. And it also eliminate nuisance odors, reduce the content of pathogens in the digested effluent while obtaining better management of waste disposal. Major components in the biogas are 40 to 70% methane, 30 to 60% carbon dioxide, and other gases is 1 to 5%. It also contains several tracer gases like hydrogen sulfide, nitrogen, ammonia, carbon dioxide, and vapor. Biogas can be upgraded to higher methane content, and that can be used as a actually fuel for cars, and also that can be used for generating electricity. So if we go deep into the anaerobic digestion process, there are actually 4 stages for degrading organic biogenic residue. So there are 4 processes. What you can see that the hydrolysis, acetogenesis, and methanogenesis. In the hydrolysis, the breaking of large compound takes place by adding water, where complex carbohydrate actually convert to sugar, complex protein convert to amino acid, and complex lipids convert to fatty acid. And the acetogenesis, actually the next process, the acetogenic bacteria able to uptake long chain fatty acids, alcohol, and these sugars and amino acids, and do the further degradation into the volatile fatty acids. And then in acetogenesis, at this stage, this volatile fatty acid actually convert to acetate hydrogen and carbon dioxide. And then methane producing bacteria, that is methanogens, are able to utilize in their metabolism and convert them into biogas, that is methane and carbon dioxide, and small quantities of other gas. So that means in this production process, there are some factors actually which affects on the anaerobic digestion process. The factors are what can be seen here: temperature, pH, volatile fatty acid, carbon nitrogen ratio, total solid concentration, mixing, organic loading at detention time, inoculum, etc. But in these factors, you can see here, there is a suitable ranges, especially if we look at the carbon nitrogen ratio is saying that 20 to 30 carbon nitrogen is the best for the anaerobic digestion process. Lower and higher than this range would be harmful, and it affects on pH and volatile fatty acid and organic loading rate. So if the carbon nitrogen ratio is low, too much nitrogen is present, leading to ammonia accumulation, and that causes either high pH value or methanogenic inhibition. If the carbon nitrogen ratio is high, nitrogen is rapidly depleted, that is poor buffering capacity, and produces excessive amount of VFS during fermentation, results in lower pH and gas production. So that means the carbon nitrogen ratio plays vital role controlling other factor and the gas production process. So to make the balance of the carbon nitrogen ratio, we need to think of the alternative way. What is that? That is actually co-digestion. There's a practice now is happening in other developed countries and other countries. So co-digestion is the simultaneous digestion of homogeneous mixture of 2 or more substrates to make a balance between the carbon nitrogen ratio and make bring the carbon nitrogen ratio in the suitable range. So there are plenty of actually residue and waste generating from agriculture, industry, and the municipality, and so that can be mixed and that can be treated and mixed with the like a major waste like cow dung and poultry doping, and can be fed into the anaerobic digester that we are calling anaerobic co-digester, and this digestion process can be taken place in single or two phase, and temperature that can be maintained with the mesophilic and thermophilic condition. The mesophilic temperature is around 30 to 45 degrees C, and thermophilic is 50 to 55 degrees C. So during the digestion process, this biogas is produced, and this biogas can be used as a heat and electricity, and with the upgrading, that can be converted to biomethane, and that can be used as a vehicle fuel and can be injected to the gas grid. And the digested can be a very nice or good fertilizer, organic fertilizer, can be used as a compost and livestock bedding. So benefit of anaerobic co-digestion, what can be seen that we can dilute the toxic substance in the feedstock and make a nutrient balance and synergistic effect on the microorganism, which can increase the organic loading rate. As a result, higher methane production can be happen, and from that we can get the economic benefit. So now I would like to give some present practice, some brief idea on the Bangladesh current practice on anaerobic digestion and biogas production in Bangladesh. Late Professor Karim of Bangladesh Agriculture University first introduced the biogas technology in Bangladesh. Later on, many organizations have been involved in the biogas sector. A major initiative was with the ITCOL, where they have constructed number of fixed dome type biogas plants in the flood prone areas, and size of plants are 1.2 meter cube to 4.8 meter cube. Rural Development Academy also installed 120 fixed dome biogas plants until now, and the size of the plant is 130 meter cube. And all are based on the single substrate like poultry or cow dung. ITCOL also finance 8 biogas-based power plants. The plant uses poultry litter as a feed material in the digester for generation of biogas and then electricity. So last plant with the total capacity of 400 kilowatt uses 400 kilowatt generator, and this has been installed in the Samyul Agro in Gazipur, but they are using now 2 generators simultaneously for producing electricity to meeting their half of their demand. Also, GIZ has supported approximately 1,500 biogas plants in Bangladesh to use cow dung or poultry litter to produce biogas on a commercial scale. Fixed dome type of biogas plant, the size of 350 meter cube each, have been installed in different locations of the Kaji farms, and they are facing problems with the poor efficiency and sedimentation of the limestone, and need addition of considerable amount of water, and they are facing difficulty to maintain these plants. Paragon Poultry Farm also constructed 2 large-size biogas plants, a steel tank reactor type you can see. So one in Gazipur of size 2,700 meter cube, capacity to generate 300 kilowatt of electricity, and other at Mymensingh of size 1,350 meter cube, capacity to generate 125 kilowatt of electricity. The unique things is this plant supply power to the chicken houses, and while capture heat used to produce hot water in the hot water tank to maintain effective temperature of the digester. But they are facing also problem with the slurry management. Now, if we make the summary, this study was conducted by Green Energy Knowledge Hub Bangladesh Agriculture University in 2016. So number you can see is estimate from the 2016. So there might be now higher number. This number that we have found, there was 91,350 biogas plant installed until that time. And there are many organizations like Environmental Pollution Control Department, BCSRI, other organizations have contributed to installing this kind of biogas plant. But trend of establishment is still towards fixed dome type biogas plants. And that can be seen also in the Jasor municipality. In recently, they have actually set up a waste treatment zone where they have installed biogas plant type. This is a fixed ton type also, and where 18 ton organic waste per day can be fed for aiming to produce 720 meter cube of biogas. But there is no heat control, no pressure sensor, nothing. If we look at the gas composition of produced biogas from different poultry and dairy farm in Bangladesh, we can see that the methane production is in the range of 50 to 60%. It's quite low. And hydrogen sulfide, especially in the poultry farm, is quite high. And we know that for producing electricity using the generator, the hydrogen sulfide should be in the safe range. It should be at least below 100 ppm. So major constant of anaerobic digestion, we have found at that time that low methane is from current manure handling process, poor management practices in biogas plant, lack of research and development facilities, though we have now some facilities to conduct research, no scalable and sustainable technology in the country, especially in the industrial scale, low number of expert and consultant, and lack of skilled manpower to run the biogas plants. And this problem still exists. And if we look at this low methane yield and poor management practices, mainly due to these biogas plants are based on the single substrate, mostly dairy and poultry, no heating, no mixing, poor slurry management, there is no temperature monitoring, pressure monitoring, nothing. So that practice needs to be improved. So rather depending on only single substrate, poultry and dairy, we might go for other biogenic residues, which can be helpful to increase biogas production as well as reduce the dependency on the single substrate. So now if we look at the biogenic residues available in Bangladesh, what we can see, especially from the major livestock, we can see in a year 17.63 million ton of available residues can be found from the residue manures can be found from the cattle, buffalo, goat, sheep, and poultry. And major share is from the cattle, 72%, and then 13% from poultry and 9% from goat. If we look at the net available residue from field-based crops, we can see that from the rice, sugarcane, wheat, jute, there is some crop residue which can be used, and this is 37.99 million ton, and this major share is coming from the rice straw, and then 13% is from the maize. So we have a plenty of sources, so that can be utilized. But of course, we have to keep in mind, because rice straw nowadays is being used as a cattle feed, so we can use the straw remaining portion which are not being used as a cattle feed. But other residues can be used easily for the biogas production or co-digestion. Net available residues from process-based crops, what we can see that there is an amount of 4.47 million ton per year that can be that are available and that can be used for co-digestion. And major share is coming from also rice bran, though rice bran is nowadays using as a producing as a cooking oil, and also mango peel and sugarcane bagasse, those can be used for co-digestion. And from the major city, we are getting also the waste, and it's around 1.995 million ton per year from the recent estimate. This number can be varied. And major waste is producing cities is Dhaka, then Chittagong, then Mymensingh. So that means we have a available alternative sources that residues or waste can be used together or mixed together for optimizing or increasing the biogas production. So if we look back this figure, so that means we have all the options: agriculture organic co-substrate, industrial substrate, municipal organic co-substrate, that can be pre-treated and mixed with the cow and or poultry dropping in a certain ratio and fed into the digester. So that means we have the options. We have to think of using those kind of options for increasing the biogas production. So if we look at the carbon nitrogen ratio, there are some feedstock which a carbon nitrogen ratio is less than 20. There are some feedstock less than 40 and then above 50. So for making balance or bringing the carbon nitrogen ratio in between 20 to 30, we can mix the small amount of like a feedstock which above higher percentage of carbon nitrogen ratio with the lower percentage of feedstock is the lower carbon nitrogen ratio. We can come into the suitable ranges. So, and that can help to increase the biogas production. So if we look at this result, these results are from the defined research data. We can see that when we they mix this cattle manure or cow manure with the other biogenic residue, the gas production has been increased, and the lower increase is 7%, and it's also the higher is more than 200%. And the ratio, you can see they maintain different ratio for producing the gas. So, and this is all scenario, the co-substrate mixed with the cow dung, and the temperature is maintained is 30 to 37 degrees C. With the poultry doping also, we can see the same scenario. In one cases, we have seen that there is a less biogas production, probably that waste was the citrus waste, and that might rather producing the biogas, it reduces the biogas productions. So for in the selection of the substrate or co-substrate, we have to be very careful and selective. And also you can see here also they have maintained a defined ratio for producing biogas, and temperature also maintained here in the mesophilic range is at 30 to 38 degrees C. So that means what you can see, by maintaining proper carbon nitrogen ratio, we can maintain the pH level, neutral pH level, as well as the volatile fatty acids, the desirable level, and then we can increase the gas production. So this is about the energy production or gas production. If we look at the greenhouse gas emission and global warming potential, we can see that we try to simulate, I try to simulate the fourth scenario, where we can see that in the scenario one, there's a poultry dropping and straw being landfill, is open landfill. And then scenario two is poultry dropping monodigested wheat straw landfill. And then poultry and wheat straw being managed liquid slurry that put into the tank, and poultry dropping and wheat straw being co-digested. So both the waste actually have been used for the digestion. So in this case, what can be seen with the scenario N1, scenario 2, where only poultry dropping monodigested, the greenhouse gas production can be reduced to 4%, can be reduced at 24%, and global warming potential as well as can be reduced. And with the 1 and 3, where actually poultry and wheat straw being managed as a liquid slurry put into the tank, there is a reduction of 47% greenhouse gas. If we co-digested, that we can see the 93% reduction. That means we have to think of using all the wastes, not leaving anything in the open air. We can really reduce the greenhouse gas emission as well as avoid the global warming potential from the waste. So in conclusion, I would like to say that present anaerobic digestion practice in Bangladesh, mostly based on monodigestion having poor efficiency and methane production. There are no heating mixing mechanism as well as monitoring of pH and carbon nitrogen ratio. Around 17.63, 13.99, 4.47, and 1.95 million tons of biogenic residue and waste are available in Bangladesh from major livestock, field-based crop, process-based crop mesocetes respectively, which can be utilized in co-digestion for increasing biogas production and reducing greenhouse gas emission. Anaerobic co-digestion can help to best utilize of these biogenic residues for sustaining biogas production by maintaining recommended carbon-nitrogen ratio and other pH and VFS. So anaerobic co-digestion will help to break the dependency on the single substrate and help to maintain industrial scale biogas plants because that plant doesn't need to be depends on the single substrate. So there are other sources that can be used for feeding into the plant. So future commercial biogas plants should come with the state-of-art biogas technology having co-digestion option. There should be options of monitoring and maintaining temperature, carbon nitrogen ratio, pH, gas pressure, and composition, etc. So I would like to acknowledge Reza, BU, and BUET team for helping me in some calculation. USAID, National Academy of Science, Engineering, and Medicine, bridging the leading universities in this novel research, and also for funding. And of course, our partner institute, Dhaka University and Florida Tech University, BUET, for nice collaboration. So thank you, everybody, for patient sharing. Thank you very much.
Thank you, Professor Chayan Kumar Saha. I think it was a very exciting talk, and we learned a lot about the current situation of anaerobic digestion in Bangladesh through your talk, and we'll talk on different parts of your talk and a little bit highlight on the things that we would like to ask you and all the panel discussions that we have, short panel discussions. So my first thing that I had in mind was to Mr. Muhammad Abdul Gofran. I had this question in mind that with the talk that Professor Chayan Kumar Saha has given, that we have seen that there is a lot of potential of biogas in Bangladesh, whereas we did not see a lot of improvement in this sector, and you are involved with this sector for a very long time. It has seen a lot of ups and downs. So why did not biogas sector see that much of attention? Or I think it got the attention, but it did not show that promise that we are looking for. So there is something missing. So what could be that other than the co-digestion part, please?
Okay, thanks, Dr. Kawnish. I start with this point, why it is not disseminated so much. The first thing, it is the responsibility of Ministry of Energy and Power, Ministry of Energy, Power, and Ministry of Power, Energy, and Mineral Resources. One important thing, in Bangladesh, Dr. Chayan told the 91,350, it is data of 2016. Recently, we conducted one survey, and according to that, it is about 1,40,000. Out of that, ITGOL, they constructed about 56,000. And BCSAR, Science Laboratory, they constructed about 33,000. Yes, that is okay. And another is Ministry of Youth. Ministry of Youth, they by this time constructed more than 30,000. But their project is stopped now. Their next project is under process. So these are the, in all, there are about 140,000 biogas plants in Bangladesh. And all are your co-digestion. There is no dry digestion technology or co-digestion. And this recently, BBDF, Bangladesh Biogas Development Foundation, and SEDA conducted one study, dry digestion, that is in agriculture, Sher Bangla Agriculture University, Dhaka. It is now functioning. This is the situation so far. Regarding technology, initially, Dr. Chayan told it is started in 1972 by Dr. Kurim. Actually, we have a high regard on Dr. Kurim. He is the first leader of biogas plant. And that was a floating dome type. We call it Indian floating dome type. And after that, in 1982, the Department of DOE, now DOE, Department of Environment, but it was EPCD, Environment Pollution Control Department. It was established by government, actually mainly for environmental reasons, but the first task it was given them, that is to construct 400 biogas plants. They constructed about 391 biogas plants, all are floating dome, and 119 fixed dome plants, but not a single plant worked due to design fault. In 1992, actually, the fixed dome plant mainly started from 1992. BCSR, LGD first constructed one plant in Noakhali district, a fixed dome plant. This is Chinese model. We call it Chinese model fixed dome plant. And now IDGOL and other, they are also following the same design. And floating dome actually initially works nice, but after 5 to 10 years becomes, due to rust, it becomes leakage formed and plants stopped. So the people, your users, they are not happy with the floating dome. So this is the design. After 2009, IDGOL and Gramin Shakti, they started thinking that floating dome, it takes time and it cannot be shifted from one place to another. So considering this, they imported, first Gramin Shakti imported 10 biogas plants from China. Fixed dome biogas plant is plastic. Yes, this is plastic biogas plant. And after that, about 50 biogas plant installed by IDGOL. That is also a plastic biogas plant. Actually, I am now running 85. So I forget something. There may be something missing, but please do not mind. Recently, the main difference is there is no coordination. At present, there is no coordination among the actors. Your IDGOL is working under Ministry of Finance. BCSL, they are under Ministry of Science. And the main responsible is Ministry of Energy and Power. They did not construct a single. That is the main thing why biogas is not expanding. It is not IDGOL, it is not their function, but the donors, they have given money to construct IDGOL, then they have started work. So that is the situation. Recently, there is great interest among the common people, bottling of biogas. Actually, bottling of biogas, it is not known in Bangladesh, but in European countries or in other countries, there are lots, not only one or two, hundreds of CNG stations running with biogas. The difference is, for bottling, biogas contains CO2, about 40% CO2. So for bottling, first thing we have to remove CO2. Removing CO2 is just one machine. The biogas is passing through that machine, CO2 removes. In Bogura RDA, they have imported CO2 machine, removal machine, and it is working. But the problem is they do not have so much gas. So for CO2 removal plant, every day it needs minimum 500 meter cube of gas. Another is, I was talking about potential of biogas. There is no survey in Bangladesh so far who can say that the potential of so much is, but BCSR and LGD, we have jointly calculated that about 4 million biogas plants can be constructed in Bangladesh. And raw materials are, Dr. Chayan knows, recently I have tried to assess the potential of maize. In Bangladesh, 800,000 acres of land under maize cultivation. And maize for single crop, 20 tons of waste is available from 1 acre. So that is the, and maize S2S CN ratio of maize. Optimum CN ratio is 25. And Dr. Chayan tested the CN ratio of maize is 25. That is, maize has required CN ratio. So maize, it has a good prospect. Another is city waste. We have already mentioned about 19 million, but 1.9 million. 1.9 million tons of city waste every day. I think it is more than that, far more than that. But there is one survey is required, assessment of potential of maize. That is important. But it is not yet done. One important thing, the different actors are working, but there is no coordination. Recently, government established SEDA. SEDA actually, they do not have any fund, they do not have any staff, they are only policy making body. So who is implementing? There is no implementing body. And there is no, recently SEDA started coordination, but still actually no one cares SEDA. SEDA should be given more. For that, I have given a proposal that there should be an act, Renewable Energy Act, and to implement renewable energy projects, there should be separate ministry for renewable energy. Like India. India, they have renewable energy ministry established in 1992 and separate department for renewable energy in 1981. And in 1987, they have established IDEDA. IDEDA, they are financing renewable energy activities. So in Bangladesh also, we should take similar initiatives. And thanks to Dr. Chayan, he has taken lots of trouble and gave a nice presentation. And thanks to organizers of this seminar, this seminar, I think we are we are discussing on biogas technology, and some recommendations will be coming out, and that recommendation ultimately they influence government policy. Thanks for all. Thank you.
Thank you. Thank you, Mr. Gofran. I think it was very enlightening to know about the chronological development of biogas sector in Bangladesh, and also we have learned about that fixed dome and floating dome situation, how it is going on, and why isn't it working. And we agreed that yes, it has to be a good coordination among the bodies who are actually implementing this in Bangladesh, so that we can see the maximum potential. So today, because we are looking at also not only this the historical development, also on the technical side. So we'd like to ponder a little bit on the problems that actually biogas production faces. From the excellent speech from Professor Shah, I think it was very clear that co-digestion has a very nice potential to overcome the current situation with maintaining the C/N ratio and producing optimum amount of biogas. But what I know also is biogas sector is also facing some sort of problem regarding the digested disposal. Before I go to Dr. Toufiq to seek for the solution, so I would ask Professor Shah to actually talk about the problem so that I can direct it to him. Professor Shah, please.
Sorry, I cannot hear you properly, Dr. Kawnish.
So sorry. So what I was saying that what I know that Bangladesh biogas sector is also facing some problem with digested disposal, as we know. So so before we seek for the solution from Dr. Toufiq, I'd like to request you to talk about the problem first.
Okay.
We can talk about that.
No, thank you.
Yes,
Thank you,
please.
Dr. Kawnish. Actually, it was a nice, informative speech from our honorable discussant, Mr. Abdul Gofran. Actually, he has actually kind of a passion and long experience with the biogas sector, and he has really given some of the picture where our biogas sector is facing different kinds of problem, and the experience that what we have. Actually, we are feeling that somehow there is a coordination, there is a gap among the researcher, implementing bodies, and also what I feel actually that there should be kind of solution. Of course, solutions are there in the developed countries, but there should be something adaptive research or kind of solution that can be adapted in Bangladesh context. And also there is a big problem with the bioslurry management, where actually there is no state-of-art solution that here in Bangladesh that private sector is using. So they are saying that if we really want to have establish a biogas plant, so we need a proper solution. You need to demonstrate us this is the solution which can be actually used for producing biogas, at the same time solve the bioslurry problem. So maybe Dr. Toufiq, who had joined us, maybe he can give us his experience in the USA, and I know he lived in Germany quite long time, so he can give us kind of probably idea what could be the state of our technology for current solution in current problem in Bangladesh, which can be solved by using those kind of technology in the biogas production as well as the bioslurry. So,
thank you, Kawnish. I'll take it from here. Thank you, Dr. Shah, for the nice presentation. I mean, it is good to know what is the current state of the art. When you move from Germany to Bangladesh, the situation is different. Although we are producing the same biogas, but the feedstocks are different, the policies are different, as well as the implementations are different. So we have to think, I mean, this is not the same solution that is applied in Germany could be applied in Bangladesh. We have to be more adaptive in our nature. And it was very great to hear the history of biogas from Mr. Gofran. It was a very interesting overview of it. And talking about the digestate is basically what is the slurry left over after biogas. So when Dr. Saha was mentioning that if you have sugar, if you have protein, if you have others, that will actually break down by hydrolysis into methanogenesis, go into the biogas. But if it has more like a fibrous substances, they will not like to break down. So the hydrolysis of these enzymes is not that easy, and this is the rate limiting step for that, the slowest reaction. So that actually end up on the slurry, and the slurry contains about like 80 to 90% of the weight, depending on the feedstock we are using. And it is very wet as well. So what can we do with the wet slurry? And for my personal experience, it does not smell good. So if you walk past to a biodigestion facility, you would probably smell the biodigested of it. So what can we do with that? The one good thing about this one is it has potential fertilizer value. So if we can use it as fertilizer, that could be a very good solution. I know Bangladesh, we haven't really adopted that organic fertilizer vibe yet, but maybe this could be something we could try to adopt it, using it as an organic fertilizer. But in the US, as well as in Germany as well, both countries are the single crop production countries. So we actually produce the crop once in a year. Very rarely we produce two crops a year. So in that case, we can only fertilize our land in once. So if we are producing the biogas 12 months a year, we are going to produce inevitably the digestate 12 months a year. So what should we do with those rest-over digestate that could be applied to the land, but it cannot just store it, and storing it would be a mountain of digestate, which would be smelly, which could actually have some other environmental effect as well. So what we have been doing over the years is try to stabilize the biogas, not the biogas, the digestate. So one of the things, a couple of technologies that we are developing. One is very appropriate for the high moisture feedstock. We call the hydrothermal technology. So basically in Germany and in the US, we are now developing, and these are actually going beyond the pilot scale demonstration. There's a couple of commercial demonstrations are coming out in the United States as well. So we can actually convert these wet digestate. We don't have to dry it, just need to put it into the reactor at high temperature, high pressure. It is going to break it down and produce different kinds of either fuel, bioproduct, and biogas as well. So these are the couple of products we are working on. There are other technologies that could be applied. We call the pyrolysis. So we can produce the biochar from it. So in biochar, we could use it. It is a stable form. There are several studies who is mentioning that the biochar can be think of as a slow release fertilizer. So in compared to your fast release fertilizer, your inorganic fertilizer, which just convert nitrogen very quickly, the slow release fertilizer would actually reduce the slow. The one good thing about the slow release fertilizer is you do not have to add fertilizer every single time. So if you add biochar once, and there's a study over there, so the crop would actually grow for the next 4, 5, or 10 cycles, depending on the biochar quality. So these are the biochar thing. This kind of char and the liquid fuel or solid fuel you can produce, they can be used as a fuel source as well. There's one study I did back in Germany where I was trying to see when you produce this kind of biochar, you could intentionally produce it as more of a very microporous and mesoporous substances, very porous. So what we try to do is we try to use it to see whether we can actually grow microorganisms in it. So the idea is to bring the biochar into the digester again, so that we have a home for these anaerobically digestion, the microorganisms. So that way we could actually produce more biogas. So these are some of the technologies that we are looking into it. The one other thing, beside the digested scenario, the other thing that come to my mind is the natural, the biogas purification and actually carbon capture from biogas. This is something that we are interested on as well. So we know we are very accustomed, even in Bangladesh as well, we're very accustomed of using natural gas, using methane. But if you cannot just substitute methane with biogas, which has about 40% of carbon dioxide. So, but if you just convert the biogas into, we call the renewable natural gas, just like a methane, separate the carbon dioxide of it. So that way you could actually use that biogas to any other sectors that are currently using methane. But you have to separate that one. And this technology, that we are actually working on several different things, and to try to do the carbon capture from biogas and actually try to utilize it as well. I know in this project, Kawnish, we are going to work on it, try to see whether we can capture biogas and convert it into methane. So I'm going to stop over here, and if somebody has a specific questions on any of these technologies, I'd be happy to explore more, but for the sake of time, I'm going to stop over here and let the others speak. Thank you.
Thanks, Toufiq. I think it was great that you gave a very brief overview of the technologies that are being under consideration in Europe and in US. So actually, I believe that it is time for Bangladesh to take the step to move forward and adopt some of the technology and adopt them in the context of Bangladesh, rather than not just adopting it from directly wherever it is used as it is. It has to be adopted in a way so that Bangladesh can take the most benefit out of it. So we are actually receiving some questions. So I'm going to introduce those questions to our expert panel discussants and speaker to answer or to discuss those questions. So first question that we got from Mohammad Imran Hussein is, instead of methanogenic bacteria, can we use chemically methanation process? So it seems like this question is directed to me. I don't know. I can I can answer this, but well, I'll take this one on. I'll pass the rest to others. I think we are talking about a biological process to reduce the energy consumption, and methanation process is a really high temperature process, and you cannot really do it in such low temperature and with this energy efficiency. So while handling waste, we cannot think about chemically methanation process. So the next one is.
Can I add something to that question?
Please.
Okay, so yes, as Kawnish was suggesting, so the chemical process and a very high temperature chemical process versus biological process, there are pros and cons on both ways. Technically speaking, it is absolutely possible. Can we convert carbon chemically to methane? It is absolutely possible. But when we do, as chemical engineers, when we do the economic assessment, it does not really make sense to actually go through it. And also think about all the contaminants other than carbon. So if you just add a lot of hydrogen to it, and also where is the hydrogen coming from if we want to do the methanation? So if we want to convert that, if we start adding hydrogen, there is a possibility of bringing a lot of hydrogen sulfide, a lot of volatile organic compound, a lot of polycyclic aromatic hydrocarbon, which have a very high the impact. And also for the sake of Bangladesh's perspective, I think we want something as a low cost solution rather than a very high cost or costly solution. So yeah, technologically it works, but I don't think it is feasible.
Thanks, Toufiq. So I think Mohammad Imran Hussain, you got the answer more or less. And again, we have another question related. I think it's a bit the digressed question, I would say, but still we can take this. Can biogas production route more favorable to be producing hydrogen by Chayan Saha? So it's hydrogen what we are talking about now. Probably the question came from the point of view that the event is organized under RehiCare and RehiCare project is dealing with hydrogen. So to answer that, I think I have to take this question as well. I think it's again about something that is not exactly related to biogas, but if you're thinking about hydrogen, yes, there are many other routes, but while we are talking about hydrogen from biomass, so this is one of the most efficient ways, so we can say, and it also depends on many other factors. Here we are talking about biogas because we are having wet feedstock. And if we're having dry feedstock, then we might have a different process like gasification. But in this case, yes, I can say that it is a favorable route compared to other routes that we can consider. But because we are not talking about hydrogen today, I would move on fast from this question and then come back to our actual topic. So this is a question, I think I can direct it to Professor Saha. What is the potential or feasibility of upgrading the produced biogas to biomethane in Bangladesh by Shahriar Hussain?
Yeah.
Professor Saha, please.
Yeah, the things is actually, of course, if we can produce biogas with high methane content, that can be further upgraded. There are some technologies that can be used for upgrading. So it depends on actually the policy of the government, the current policy and the future policy that we want to go. So this is very important. And of course, as for example, in Sweden, they are using biomethane for a running vehicle, and as well as waste heat for heating their household. So and even there was interesting news that Sweden is importing waste from the other countries. So that means if we really can manage the city waste in the proper way, we can use if we can use the state-of-art technology that are being used, those are being used in other countries, developed countries. So we really can manage all those waste and really can have a really good potential. One thing we have to keep in mind, we are not only producing energy, at the same time, we are reducing greenhouse gas emission. That what we are looking for in the sustainable development goal. So that's something probably we have to keep in mind. So we really need to focus in the biogas area, especially in the biomass or biogenic residue area. And we really need to go for technology like that, which really works in Bangladesh. As for example, many companies are coming, many donors are coming, they're saying, okay, just I'm giving some money, so use that kind of technology. But we have to be very selective for choosing any kind of technology for Bangladesh context. We should not compromise anything that will be harmful or that will not be beneficial at the later end. So that's something we have to keep in mind.
Thank you. If no one else is going to add anything, so I'll go to the next question. It is about the biogas sources scattered in the various parts of the country. So the question is asked by Yasir Arafat Siddiqui. he asked that how can we centralize the sources for maximization of the biogas output? Is there any plan or policy under consideration? This is an open question, so I believe I seek for answers from everyone. Or
maybe I can start with, and then
okay.
Mr. Gofran can add something, or Toufiq can add something. So the things is actually government has planned to actually establish centralized energy production site. As per example, from the city, they have planned to produce energy. So that's something that what I told before, that we have to be very careful in selection of the technology which will produce energy. Of course, for centralized system, there was another question actually, how in the complexity, how this how this waste can be collected and produce the centralized use the centralized system for producing energy. So the things actually again that I would like to tell, that there are some examples, there are some practice already. So that might we need to adopt it in Bangladesh. And if we can segregate the waste from the source, it will be very easier to handle, and it will be very easier to use, collect and use for producing energy. But if we, as for example, if we collect all the waste together, and then if we want to do that segregation in the centralized location, that would be quite difficult to manage all those waste, segregate and put into the digester or other incineration plant. So that's something we have to actually keep in mind, whether we want to collect the waste from the source or we want to segregate the waste at the central depot. So that's something probably we have to think of, but it's possible.
I can add something to it, and let's see. So when we're talking about the wet waste collection and transportation, so so how far can the wet waste transfer? So that there is so if we are using a truck to transfer waste with 90% of water or 95% of water, I think the study shows that we cannot travel. So the amount of gasoline we are using to transport the waste and the break even is about like 10 to 15 miles. So if we are transporting waste more than 15 miles, we're actually paying more for the gas than the actual the generation of the energy out of it. So this is something we need to pay attention. So where should we build this centralized facility? Which part of Dhaka, if we are considering Dhaka? Because we cannot just use any centralized facility in Dhaka. It has to be transported to outside. So in the United States, we do transport it in the train. So we have the train system. We have so many 20 or 30 bogies filled with the municipal solid waste and train it from one state to other state. Economically, it is not viable, but they were doing it for political reason. But anyway, I'm not going to that discussion. I just wanted to give a little bit of idea of transporting wet waste is a problem as well. So if there is probably Dr. Saha knows it better, if there is a possibility to make it like a decentralized biodigester facility, or probably a modular biodigester facility, that might actually work better. But again, I mean, the scenarios are different. The cost would be different as well, and how we are maintaining it.
I completely agree with Toufiq. It is going to decompose. First thing I wanted to say, it is going to decompose while transporting, so it is not going to happen. So somehow it has to be converted at the source if it's possible. That is the best possible way to convert the carbon to biogas. Otherwise, the whole idea of producing biogas becomes really not so attractive and not so economic. So that would be the answer for this, I guess. So it's in combination, we can say that this is centralization is not the best policy in this case. Now, there is another question. I'd like to direct it to Mr. Gofran, is about bottling biogas. What are the possibilities and challenges to have biogas in cylinder to use at remote places, by Zakir Ahmad? You mentioned something about the bottling of
Yeah, actually,
so
the answer is very
you
simple.
might be able to answer.
Answer is very simple. For bottling, we need one machine, and that is very costly. And that is possible only if the sufficient quantity of gas is available. Bogura RDA, they have taken initiatives about 5-6 years back, and they have purchased all the equipments, everything ready, and they purified using that gas. They run vehicles, so everything okay. But the problem is that machine that needs sufficient amount of gas that they do not have. So to run that machine, they need a big digester. Very simple thing. And if you can construct a big digester, that means at least 20-30 tons of waste per day. If that can be available, then your bottling is possible. And another thing, bottling for domestic use, the cylinder weight is 15 kg or 16 kg. But for transport use, the cylinder weight is more than 60 kg. That cannot be handled. And that is also not heavy. In cylinder, gas is compressed at a pressure of about 3000 psi or 200 bar. In 200 bar, the cylinder thickness is very thick. So you cannot handle it for domestic use. It is not feasible. But for transport use, transport fuel, quite easy, no problem. I think at least one. If Mr. Toufiq Reza take initiative, he can start at least one. I think if we can start one, there will be hundreds of people coming to with the proposal. Yes, everyone will come forward. So Toufiq Reza can take initiative to install at least one.
Thank you. I think the answer was sufficient that it is expensive and it has to be a commercial size biogas production plant. It is not of course.
Actually, can I take 1 minute?
Challenge? Even CP waste considered.
Can I take 1 minute?
Sure, please. Yes.
1 minute.
Yes.
Actually, what I've forgotten. Sorry.
Now, maybe I can add a little bit on that what Dr. Mr. Abdul Gofran Kawnish was telling. Actually, the things is that people are skeptical and lack of confidence in investing in the biogas sector. So what Mr. Gofran said, if there is a kind of good example with the practice, state-of-art practice in Bangladesh, there are many investors who will come forward and invest in the biogas sector, but they are looking for someone who actually really take the initiative and use this bottling or use as a vehicle fuel or use the state-of-art technology for producing biogas. So that's something we are still lacking. So that needs to be established here in Bangladesh.
Actually, I wanted to say For electricity production, for running a generator, no purification is needed. Raw biogas can be used for running generator. There are hundreds of generators running with raw biogas. So that information I am giving.
Okay, thank you. And we have the other question that I mentioned is, what is the major challenge for commercial production of biogas using city waste in Bangladesh? So I'm directing this to Dr. Saha.
No, that's actually probably I have answered that. Major challenge is the segregation of the city waste and the collection, and that is a major challenge. And if we of course do that in source, that would be very helpful. What the developed countries are practicing. Otherwise, it would be really difficult. I can see in Joshua they are collecting all the waste and bringing to the one centralized depot, and then there they are doing the segregation, but they put a lot of options, like they have a digester, they have a kind of other incineration options and everything. So and I could see that way they also they have a kind of composting plan, the aerobic composting option. So in terms of generating fertilizer is okay, but if we look at the global warming potential, it's not the ideal way to practice. So that's something, the dilemma that we have to fix it, and we have to really understand what we want to do, because we will not only produce the fertilizer, we will not only produce the energy, at the same time we have to think of reducing the greenhouse gas emission, because you know, Bangladesh is one of the vulnerable country in the current global warming potential and the climate change.
Great, thank you. I think we have covered many of the questions, and we are still receiving a few questions. I think we can take one or two more questions, and after that we have some participants who have raised hands, so we'll ask them to speak to discuss with our discussant. So another question is from Shahabuddin Ahmed. How can we raise public awareness about the potentiality of bio-waste, and has any measure taken in the past? How do the developed countries manage their lots of bio-waste? I mean, the amount of bio-waste, the quantity, how are they handling that in developed countries? So it's I think it can be, this answer can be shared between Dr. Toufiq and Dr. Saha.
So I'll start how the developed country does it. So and again, I'm going to share in two different continents. So in Germany, Dr. Shah was there when I was there at the same time. I'm pretty sure you remember that in our house we have 4 different bins. So one is for the biogenic residue, no plastic. One is for recyclable. One is for paper. So this is something that we are sorting it, as Dr. Shah was mentioning, we're sorting it at the source. And when it comes to the collection case, they only collect the biogenic residue, and they use the biogenic residue in biogas plant directly. So this is something that the Germany was doing. And one of the reasons they were doing is because they don't have enough land. When it comes to the United States, we have plenty of lands, and more lands becomes more landfills. So we do not segregate that much. We actually, the most practiced way of handling bio waste in this at this time is just landfilling it. But in the last couple of years, it is raising a significant amount of awareness in the United States, and we are taking so many initiatives on how to segregate, how to separate the waste from not the waste, the recyclable materials from the municipal solid waste, and use it to the disposal. Again, if we do the landfilling, but from the landfilling there is a certain the EPA criteria that they have to follow, and then there is a gas coming out we call the landfill gas, which is not exactly same as biogas, but it can burn to some extent. So use it in that sector, in this sector as well. But There are things going on in the developed country as well. I would love to say that it is the problem has been resolved in the developed country, but in the United States, no, it has not. The government is still under the research mode, if you can think of, to actually sort out what to do with this huge amount of biogenic waste and how to deal with that. So I'm going to stop over here, and Dr. Saha might actually take it from the Bangladesh perspective.
Yeah. Now, thank you, Dr. Toufiq. Actually, it was nice provide the nice views of Germany and American aspects. Actually, regarding the awareness of the people, actually, that what I was trying to say. Actually, we need to show our people the real, actually, ideal practices, and there we need a big initiative from the government side, from the extension agency, as well as coordination between the education and research. And we really, as for example, if we I can provide one example for popularizing mechanization in agriculture in Bangladesh. Government has provided 3,020 crore taka for introducing good machines to the farmers with the subsidy, 50% and 70% subsidy. So this kind of initiative also needed in biogas sector for managing the biogenic residues and the waste from the cities and from the agriculture. So initiative is very important, and what Mr. Gofran said before, that coordination is also very important, which we are lacking. So if we want to really aware our people, there should be a nice coordination, and there should be a kind of extension planning with the proper state-of-art technology demonstration. So
I think it is. I have also seen that same practice in Sweden as well. When I was there was the source segregation, which they are practicing to separate out all the different kinds of waste. So that is probably the best way to do it, considering all the developed country practices. So other than that, Dr. Shah carefully talked about the other aspects of this issue. So I think we can take one more question, and after that we have to open the floor. That is from Sheta Tori about using biogas for households and other different sectors. Will the pricing be reasonable enough for the people of every sector? So I think this is an open question. I would ask first whether it is reasonable in US. If it is reasonable in the US, then we can come back to Bangladesh and say, okay, whether it will be reasonable in Bangladesh as well from economic perspective.
So the short answer is no. Whenever in the US, the oil price, historically, the oil price is always low. So we want our very cheap natural gas. And because we do the hydraulic fracturing, we call fracking, that means that the natural gas is becoming cheaper than water. So now what can we beat the cheaper than water? Now the government comes out to that. And this is when I said that natural gas, I try to say it is a renewable natural gas. So when you have a renewable natural gas part of it, then you have the government subsidy associated to it. So there is something that in the US, we currently don't have the carbon credit. But they are thinking about this kind of carbon credit under this administration. So carbon credit subsidized, then it will be possible. But if you are thinking about in the United States whether the biogas price can compete with that natural gas that produced by fracking, no, this is not a good comparison. But with the subsidy and the government initiated, it might be possible. But things have changed. Things can change from country to country. For example, if you go into Sweden, they don't have natural resources that much, so they need to import petroleum oils as well as natural gas from other countries. So at that point, the price is getting more and more expensive. So here we can actually have a comparison. That's what I can think of. I know Bangladesh, we have probably depleted our natural gas resource, right? Kawnish?
Yes, we are going to deplete in a few years actually. So that will be an alarming situation. So for that, there are other plans in hand. So we are getting other source of fuels and fuels for energy production. But yes, of course. So our natural gas is actually depleting. So regarding the price in Bangladesh, I think Toufiq already answered part of it.
Yeah.
So still,
actually, it's a important question, but difficult to answer straightforward. Considering the production and the pricing, actually, it might not be actually profitable at the current stage if there is no subsidy. And of course, if there is a higher price difference, then there might be we can consider that is profitable. And in just I would like to provide one example. There is a centralized biogas plant. There are many. Of course, I would like to provide one example where I have visited in Denmark. They have a biogas plant. The people living in that area, they are providing the cow dung from their dairy farm, and they know how much they are providing and how much was the total solid percentage. So on the way back, they take the biofertilizer, considering that how much they have given, and the way back they take the fertilizer to apply in their land. So this is something kind of win-to-win situation. So because they have a strong regulation, if they want to have a dairy farm, they should reduce the emission at the certain threshold level. Otherwise, their dairy farm will be shut down. So that means they are rather open dumping. They are providing their cow dung or slurry to the digester, and way back they are getting the biofertilizer, and then they are applying directly to that their field, and they can, and in one practice in Europe, they can actually apply liquid bioslurry directly to the field. So this is something that for Bangladesh context, it will very country to country. So we find our own way to make this sector profitable and sustainable.
yes, I think we can agree on that point, that it has to be profitable at some point with some sort of motivation from the government and other bodies, which has to provide some sort of incentive to actually process this sort of waste to energy and relevant products. So
yeah, one other thing I would like to add is the value of co-products. So anaerobic digestion, if we can think of, the main product is biogas, but there could be other co-products as well, and they have their own value. For example, if we are producing fertilizer, organic fertilizer, that has its own value. In our lab, we are trying to convert it, the digested, into other carbon material. That is, we're trying all sorts of impossible things. For example, we're trying to make battery out of it. So a battery material that could come with its own value of it. So once we add all of the co-products as well as the main product, all of a sudden the value become probable. And also not to think about the feedstock. So whenever I do the calculation considering municipal solid waste, I use the feedstock price is negative $55 per ton. So this is, we call the negative value feedstock. So if there is something down there, over there, so as Dr. Saha was mentioning, that it is a win-win situation. Somebody needs to dispose their waste, but we can use it to produce valuable products. I think in that case, the economics will make sense.
absolutely. I would like to show the people behind the screen who for organizing this event. Yes, so this is the young team behind this this event who has worked for organizing this clean energy seminar. So I'd like to thank them all, 4 of them, and Thanks to all the Rehaker partners for disseminating the information and supporting the event from BUET, BAU, DU, and Florida Tech. And if you are interested, please visit rehaker.com, and there you'll find more information about the future events. And I'd like to announce here as well that we'll be having student events as well in very near future. So in no time we'll be back with a new seminar. And other than that, just thank you for being the wonderful audience that you are. And until we come back with a new energy seminar, stay safe and stay healthy. I'd like to thank again all the participants and our speaker and panel discussants.